All right, so my name is Matthew Fredrickson. For those who are not familiar with me, I'm the project lead for the Asterisk project. I just want to start off first and ask how many of you are familiar with Asterisk? Okay, this is great. I wasn't sure. It's been around for a long time, but the world has changed quite a bit, and I just want to make sure that I understood the audience I was speaking with. So let's get started. For those of you who are familiar with the background of the Asterisk project, it was kind of the baby of Mark Spencer, who started the company Digium about 15 years ago, or around 15, 20 years ago. And so it's been a critical part of Digium. There's been a lot of developers within Digium as well as outside of Digium that have contributed to it, but Digium has kind of been a big part of Asterisk's life for a very long time. And just this last year, for those who aren't familiar, Digium was acquired by a company called Sangoma. And you may notice that Sangoma, the new Sangoma logo, for those who are familiar with the old logo, has acquired a little bit of Asterisk flair to it. So yeah, I mean, the world's not on fire or anything like that. For those that are concerned, the Asterisk is still a very important part of Sangoma. It was an important part of Digium, and now is also a very important part of Sangoma as well. They have a lot of products and projects internally that utilize Asterisk, and so it's still safe in terms of its company stewardship. I just wanted to talk a little bit today about some of the things that happen. That's what I try to do. Is for those of you that are not able to attend the yearly Asterisk conference in Astricon, I try to come here to this conference to be able to update everybody on what's happened in the world of Asterisk. Just by a raise of hands, how many of you utilize Asterisk somewhere in your network or deploy it or something like that? Oh, this is wonderful. All right, great. How many of you develop applications based on Asterisk? So maybe not like utilizing pre-built functionality in Asterisk, but maybe like utilizing APIs and things like that in Asterisk to build higher level applications. Yeah, more hands raised. This is great. Actually, this is really good. Okay, cool. So I'm going to talk about some things that are probably going to be interesting to many of you. Just kind of in review, Asterisk 15.x received a number of bug fix releases this last year. This is actually pulled from a lot of my slides from Astricon, which was in September. So some of the numbers may line up more with September's timeframe. But the current version of 15 is 15.7.1. Current version of 14 is 14.7.7, and actually it is dead. It is end of life because it was a standard release, and it went end of life right around the time of release 16 back in September. And Asterisk 13 is still, it is an LTS, and it is still current. There are still new releases that are made of that branch and will for the next few years. Over the course of the past year since Astricon, there were 3,300 merged code reviews across all the branches that we support. And for those of you that are not familiar with the development model of Asterisk, is we support multiple release branches at the same time. We have a very good test infrastructure in Asterisk, and allows us to be able to be a little bit more bold in terms of how we manage those branches. And we even allow new features and functionality that are non-breaking to enter those branches, assuming you don't break anything, and also that you add tests and things like that for that functionality as well. So we have kind of a non-traditional release model or inclusion model for our branches, but it allows us to be a lot more flexible in terms of delivering code to people a lot quicker. So 3,300 code reviews is a lot. That means there's a lot of work that's going into the project at a developmental level. It means it is very much a very active project in development. It takes a lot of time to do those code reviews and a lot of maintenance. So those of you that are developers, I would urge you to try to participate in that process as well. It's a good way to learn the code base if you're not familiar with it, and it helps to keep improving the quality of the submissions and things like that. And so I mentioned this already, but Asterisk 16 was released a few months ago. For those that had not heard, it included over 1,000 different commits, so that's almost 3 per day. Of those commits, there were 72 distinct or different contributors, and actually now we're up to 16.1.1. So there's been there's been at least one major release since then. So for those of you who utilize Asterisk in production environments, sometimes there are 3 magical letters that might matter a little bit more to you, and those are the letters LTS. In Asterisk world, See, those letters mean different things to different projects, but in Asterisk World, that means that that branch receives 4 years of bug fixes and 1 additional year of security fixes. And some of the LTS branches in Asterisk World are the 11.x major version, the 13.x major version, and anyway. So standard releases are shorter. There's a year of bug fixes and an additional year of security-only fixes. And some examples of standard releases in Asterisk versions are 12.x, 14.x, and actually 15.x. And you're probably 15. Yep, 15 is a standard. Okay, so good. I'm glad you brought that up. So I want to talk about this because 15, we made a decision with 15. We made some major changes to the core of 15, including multi-stream video support, multimedia stream support for calls and things like that, that we wanted to give some more time to bake before we included it in a long-term supported release. And so we broke convention. So typically the odd numbered releases are LTSs in Asterisk World. Historically, that's what they've been. But we broke convention, and 15 was a standard release instead of an LTS. Anyway, that's kind of the background there. Asterisk 16 was things have gone well with the multi-stream changes. They've been surprisingly stable. They've worked very well in terms of our targets and goals with them. And from an architectural perspective, we felt that they were ready to go in. And from a stability perspective, we felt they were ready to be baked into a long-term release. And so 16 actually got graduated into into an LTS. And so it should be around until at least 2022, and in terms of bug fixes, and should receive an additional year of security fixes and die hopefully a quiet death in 2023. So Asterisk 16, what happened in Asterisk 16? So actually tons of things happened in Asterisk 16. 1,000 commits. My job as project lead is to go through those commits and curate things and try to fit it into a 20-minute time period and talk to you about it. So I'm going to talk about flashy things, but there's the new flashiness, right? But there's actually a lot more than what I'm talking about that actually happened and occurred. So mostly I'm going to focus on some of the big pushes that in terms of big project level pushes that we've pushed for the last few years, and that's a lot on the video side of things, and making Asterisk a better media platform, multimedia platform. And then we're going to talk a little bit about ChampPJ SIP as well. So in Asterisk 15, we did as I mentioned, we did a lot of work to improve the video. We made the Asterisk code base suitable to be used in an SFU, multi-stream SFU type environment. We extended it, and it was a lot of fun. It was a lot of work, but it seemed like it went well. In an effort to get that code out quicker and to make things happen, we kind of took a sledgehammer approach in terms of video quality and video packet loss. And what we essentially did was we told the other end so for those that aren't familiar, with video, it's very sensitive to packet loss. If you have RTP packet loss, you start seeing funny things happen. People freeze, or if you have video corruption, you have pieces of body parts flying across because the video decoder context. I'm sure many of you have seen that before in different video applications and things like that. But it's an unpleasant experience. And so what Asterisk 15 did to remedy packet loss situations was it requested a full video frame from the remote end again in kind of a sledgehammer approach, which is suitable, but it takes a lot of bandwidth and sometimes can have latency implications as well. And so there are some better technologies to handle that, more finer grain technologies to handle that in browsers nowadays. And one of those is called a NAC, is the NAC message, our TCP NAC message. And so we implemented support for NAC, which is essentially a request for a retransmission of a video packet. And so that went in, and it made a big difference in terms of how much bandwidth it takes to fix packet loss and things like that. There's another technology we added support for, which is widely deployed across browsers, called REMB, and it's the receivers. So in video, it is the receivers. I guess it could apply to audio as well, but primarily it was built out to be used in video and is used in video, but is the receiver's perception of the local bandwidth that it has, right? So for example, if you're on a low bandwidth connection and somebody's transmitting video and they're in a high bandwidth connection, they're sending 1.5 MB of video to you. and you can only receive 64K of video, some teeny tiny stream. There is no way that packet retransmission is going to fix that problem, because you're in a situation where there's no way to send a 1.5 meg stream down a 64 kilobit pipe, right? So in this case, this allows the receiver to send the remote end that it's only receiving approximately 64 kilobits, and allows the transmitter to change the video encoding rate to be something a lot smaller, right, to fit in that pipe. So it's a good technology, especially when you've got heterogeneous networks with different last mile speeds and things like that. We added support for what we called enhanced messaging. So as part of the work that we did to build SFU support in Asterisk, we focused a lot on the multimedia part, or the media part of it, like the video and the audio and making it all work together. And we added some REST. For those of you familiar with Asterisk REST interface for programmatically control it, we add some hooks for the multimedia video stuff in the REST API and things like that. And then we built our fun engineering prototype. It's not very pretty by the world standards, but as engineers that don't do front-end programming, it's what we got, right? Patches welcome. So we realized that we built out that experience where all those video people were there, but we realized that we didn't add APIs to be able to correlate those video streams on the client to like caller ID information or specific participant-related metadata or information. And so we kind of, after we realized that, we kind of hit our head and said, oh man, how did we miss that? And so we added support to be able to, within the conferencing application with Asterisk, to be able to send participant level information, to be able to correlate, okay, this media stream matches up to this participant information, this caller ID information, maybe this identification value, so you can do lookups and things like that in database, and build rich clients and things like that. And so that was one part of it. Another part was being able to do participant-to-participant messaging within the context of that conference bridge as well. So if you're trying to build rich applications on top of the Asterisk SFU environment, one thing that you probably want to do is have participants be able to talk to each other via text, or be able to send information back and forth to each other. So we added support to be able to bridge SIP messages back and forth between the participants. And they can be plain text, or you can do like base64. They can do any kind of MIME type that you can think of. And so you can send binary encoded data and things like that as well. Like if you want to send photographs or images and whatever else you can imagine might fit in your application. The other thing I want to talk about is PJSIP and performance improvements. So for those of you that deploy Asterisk, how many of you are familiar with Chan PJSIP? Okay, so not so many hands as before. How many of you are familiar with Chan SIP? Maybe a few more hands. So the history there, for those who are not familiar, is Chan SIP is the legacy SIP channel driver. We took a step back a few years ago, and we realized that Chan SIP was getting to the point where, from a code-based perspective, it was very difficult to make bug fixes and make improvements and things like that. We ran into a situation where we would fix one bug and we would inadvertently create 3 more. That kind of situation. And as developers, that can be very challenging to start from that situation and try to move to a better situation through iteration. So what we did is we took a step back and decided to take all the things that we learned about SIP in the about 10 to 15 years that we'd developed on Chan SIP, and we built a new SIP channel driver using all those lessons that we learned called Chan PJSIP. And so Chan PJSIP is the successor to Chan SIP. If you are building applications with Asterisk that utilize SIP, Chan PJSIP is the channel driver you should be using. And we want to make sure that there's no good reason that anybody would want to continue to use Chan SIP. So we found at an AstriCon, it was not this last one, but the one prior, somebody presented a paper or a presentation about Chan SIP, and there were in most cases, Chan PJSIP performed better, but there were a couple of cases where Chan SIP had a slight advantage over Chan PJSIP. And so we wanted to address those because we want everybody to use Chan PJSIP, and like I said, have no reason to go back to Chan SIP. And so what we did is we took that case. It was a case of inbound SIP registration performance, handling inbound SIP registrations and how many registrations that it could handle per second. And if you look at these two graphs, this is the before and this is the after. And the bar in blue, the y-axis is the percentage of CPU utilized. So lower is better. The x-axis is the number of registrations sent per second. So registration messages per second. If you can have a lower bar, that means you're better. In previously, so the graph on the left, you'll see that ChanSIP, the blue bar, had about, it looks like about 5 percentage points difference in terms of, it was about 5% better in terms of registrations per second, all the way up to the 300 registrations per second case. If you'll notice on the right, after we looked at that and tried to fix some things there, we managed to fix that problem. And you'll notice now that ChanPJ-SIP performs about 2% better in some of those 1, 2, 3% better in that particular use case. Now, I want to talk about something in these graphs that are, there's a glaring missing bar on the 350 registrations per second. We found out, so ChanPJ-SIP is built in a way to handle multi-core processors very well, to scale across, do protocol processing across multi-core processors very well. We found that ChanSIP was unable to handle past 300 registrations per second without basically failing. ChanPJ-SIP was, though, so 350. So we decided to run some more tests, and we found out, we brought it up to 2,000 registrations per second, and we found out with this simple system that we're doing benchmarking on that, again, ChanSIP could not get past 300 registrations per second, but ChanPJ-SIP was able to handle 2,000 registrations per second on this particular system, and it probably could have kept going. There's still some more headroom. So there are no good reasons to use ChanSIP. And if you can find one, I would love to hear about it, because we want to keep making sure that there's no good reason to go back to it. I guess going further, we actually found some more things that we could do to improve performance in ChanPJ-SIP. And if you'll notice that the delta, what before was only a 1 or 2% difference between ChanSIP and ChanPJ-SIP, in 16.1, which is the most recent release of Asterisk, we continued to widen that gap. And so now it's like 3 or 4% difference. So we're continuing to whittle away on that. So anyway, I thought that might be interesting to see. So I want to talk a little bit just for a moment about what's happening next. So what's happening after 16.0? Well, we've done some work to do more performance improvements. After you've done a few cycles of major feature additions and things like that, like we have for the last few major releases of Asterisk, I think inadvertently there are some places that maybe you made performance worse in different parts of the system, different use cases and things like that. So Asterisk 17 is one of our big things that we're going to work on, is going back and benchmarking things, trying to figure out if there are situations where we made things worse in terms of performance, and try to continue to improve that, try to push that performance bar. We also added some support for those of you that utilize Asterisk REST interface to be able to filter events so that your REST applications don't have to receive every single event that comes from Asterisk, and be able to have to process each one of those and reduce the load on your REST application. And then we also have added so far some support for doing REST applications without having dial plan as well. And that's actually in a code review that should be going in probably soon. And I think that's pretty much it. My time is running short. I had to make this really fast, so this is a lot quicker than I usually spend on this. But just as a reminder, like I said, Asterisk 14 went end of life in September. So if you're on Asterisk 14 or utilize features of Asterisk 14, it's a good idea to get off of it and at least move to 15. But even 15 now is in security fix only mode, so 16 might be a good place to park. And so also I would counsel you, for those of you that run Asterisk in production or utilize it, is keep it, there's a desire a lot of times to stick to LTSs, but it would be a good idea to make sure you keep on top of what's happening in the normal releases as well. We generally try to make new releases of Asterisk as boring as possible for users. And by boring, I mean we try not to break things or surprise you about things, right? If there's new functionality, we try not to make it so that it regresses the way it impacts the way you use it in an existing way, and it is an extended type experience. But sometimes we miss things. And so it's always better to catch those things early and report them early while we're still working on them, because we're better able to go back and address those things as well. And that's pretty much it. Thank you guys very much for your time and for letting me come share with you a little bit about the project.